Carrying on with having a look at different graphical representations of data, we are going to start to have a look at stem and leaf diagrams. So stem and leaf diagrams are used to represent the distribution of data in an easy to understand form. However, it is not easy to see the difference in similar groups, and it only looks at the shape of the distribution, not the actual distribution of the data. It also makes it quite simple to find things like the mode and the median, but it doesn't make things easy to find the mean. Now, what's quite important about a stem and leaf diagram is that you have to spread the data out evenly. So here we have 16 students sat a maths test. Here are their marks, and we're going to draw a stem and leaf diagram for this information. So we're going to start off with our stem, and then we're going to do some lines going across, and these are what we're going to write our leaves on. And in order to be able to actually see the distribution of the data, we have to make sure that we don't miss any numbers out on this side. So having a look at the data here, the smallest number I can see is 39. So that means I'm going to have to start with 3, 4, 5, 6, 7, and having a look here, I don't need to do an 8 because there's no numbers in their 80s. Now, it's completely fine if you want to do a rough copy of this first and then a neat copy where the numbers are put in order, because we want to put the second digit of these numbers into our leaves, and we need those numbers to be in order. I'm going to try and do it all at once on this diagram, just to save me a bit of space, because I'm going to use this side here to do some writing. So, as we said before, the smallest number is 39. So we've already got the 3 here, and we're going to put the 9 on this side of the line. So now there's no more 30s, and now we're going to have a look at the 40s. So I can see a 45, a 49, and a 44. So the smallest one of those is the 44. So I've already got the 4 there for the 40. And then straight underneath the 9, I'm going to do another 4 for the 44. The next smallest number in the 40s is the 45. Again, we've already got the 4 here for the 40 part of that. And then we're going to do a 5. I'm going to leave a little bit of a gap, and then I'm going to have my 5 there. Lastly, 49. Again, leaving a small gap. The 4 is already there, so we're just going to have a 9. So that's all the 40s done. Moving on to the 50s, I've got a 50, a 51 and a 55. So 50 is the first one, the 5's already there, so I'm just going to put a 0 again underneath the 4, trying to make this into a nice line here. Then a 1 for the 51. Then a 5 for the 55, again straight underneath the 9. So that's one row, that's one row, that's one column, sorry. So next I'm into the 60s. I've got a 62, a 64, another 64 and a 67. So I've got a 2 for the 62, a 4 for the first 64, a 4 for the other 64, and then a 7 for the 67. I've only got 70s left, so that's good. I haven't missed any out in these top groups here. So I've got a 72, a 73, another 73, a 77 and a 79. So I'm going to have a 2 for the 72, a 3 for the first 73, another 3 for the next 73, a 7 for the 77, and then a 9 for the 79. Now, if you were to turn your head clockwise, 90 degrees, a bit strange, but you can see here that at the beginning of the data, we only have a small amount, and as we continue, we're getting more and more pieces of data in each group. So when we're trying to describe the spread of the data for part B here, if I just quickly skip back to the section where we had a look at skew, sorry, it's quite a bit ago. Here we go. It looks like this. We have a few pieces of data at the beginning. If this was turned clockwise, let me see if I can do that. No, it won't let me move it. Okay, so this was turned clockwise. We'd have a small piece of data, a bit more, a bit more, a bit more, and then we'd have the bigger ones, and then it'd start going down again. So it doesn't start to go down again, but it's definitely got a negative skew. Oops. However, first of all, we need to finish off the actual stem and leaf diagram. So we've got this bit here now. We also need to add a key. So what the key does is it tells us how to read these numbers off, because we can use this to represent decimals, we can use it to represent 3-digit numbers. Here we're using it to represent 2-digit numbers. So if I have a 3 and then a 9, that represents 39 marks, because we need to have some units on here. Okay, and that's our key. That tells us how to read off values from here. The distribution is, as I said here, we have a negative skew. So now I want you to pause the video for a second and I want you to give the Now You Try a go, remembering to spread the numbers out evenly. This time, however, in our stem side, this side of the line here, instead of just having 1 digit, we'll have 2 digits on this side of the line, and we'll have the last digit on the right hand side of the line. So hopefully now you've given the Now You Try question a go. As I said, this time we're going to need to have 2 digits on the left hand side. So the smallest number that I can see is in the 150s, so that means that we're going to have 15 on this side of the line, 16, 17, 18, and I can't see anything that's in the 190s, so that's as many as we need. So having a look through the data, we have 156 and 159. So we're going to have to start with the 6, which makes 156, and then the 9 for 159. So that's 156 and 159 done. Next we're looking at the 160s, so I can see 161, 162, 163, 168 and 2 169s. So we're going to have a 1 for the 161, we're going to have a 2 for the 162, we're going to have a 3 for the 163, we're going to have an 8 for the 168, a 9 for the 169, and then another 9 for the other 169. There's no 160s left, so now we're going on to 170s. So we've got 170, 170, 173, 173 and 177. So a 0 for the first 170, another 0 for the other 170, a 3 for the first 173, another 3 for the next 173, and a 7 for the 177. And then next we've got 182. There's no other numbers left, so we're just going to have a 2 there for our 182. Now, just as we did last time, we're going to need a key. So this time, if we have 1, 6 and then 1, that means 161. And we need to tell people what that means because it could mean 16.1 or 1.61. So we need to be able to classify this. And this time, that is centimetres, and that is our key. Now this time, we have our bulk of data closer to the beginning and then it trails off towards the end. So this is a positive skew. As I said before though, we can also read off the mode. So here, because I've only got 1, 6 and 1, 9 on that line, 1, 2, 1, 1, 1, 1, 2, 1, 3, 1, 8, but then I've got 2 9s, that means so far my mode would be 169. However, I've also got 170 and 173. So all of those are my modes. So if I was trying to read off the mode from this, I would have 169, 170 and 173. Similarly, for the example, I would have for my mode only 1, 9, 4, 5, 9, 0, 1, 5, 2. I've got 2 4s here though. Checking I haven't got anything in 3s. 7, 72. I've got 2 73s. 78, 79. So my modes are going to be 64 and 73. Obviously, if I had one where it was 3 of the same number on this side in the same line, then that would have become my singular mode. So not only that, but as I said before, we can use the data to read off the median. If I wanted to do that, the easiest way to do it is crossing off numbers from both sides, which you might have done before. So if I cross one off from that side, I need to cross one off from that side. And you can see how when I've crossed them off, I've done this in opposite directions. This does help. Obviously, you could also pop it in your calculator, but if you were asked to use the graph to do it, you could do it this way. So I've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that means it's somewhere between 62 and 64. So my median is 63. On this one, we'd have, and notice from the beginning, from the top bit, I'm working along like that from left to right. From the bottom though, I'm working from right to left because I need to start at the biggest number in that line, not the smallest number. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it's between 169 and 169. So that means that my median is 169. So that's what we'd do if we had to use the graphs to do that. Another useful thing that we can do, because we do have the graphical calculator, if I just rub this working out off here, I've got these numbers here. Now, the downfall with a stem and leaf diagram is that if you have vast amount of data, it's very hard to put it in order. Because here we only have a small amount, it's quite easy to pick out the numbers in order. But if we had a very large data set like we come across in real life, it'd be very difficult to do this. So, in the graphical calculator, if we go into the stat mode, just let me delete what I've got in there already. And if I type my numbers into my first list, so I'm just typing the data in that's here. So that's 173, 162, 170, 169, 163, 173, 156, 159, oops, 161, 168, 177, 182, 170, 169. Just quickly double checking that. Okay, and then if I go across, we have this thing here called Tool. If we click on F1, we can see sort as and sort disc, and that means sorting in ascending order or descending order. So if I put this into ascending order, oops, let me do that again. Tool, sort ascending. Which list do I want to do it to? I want to do it to list 1. And I want to put it into list 2. Oops, sorry. Try again. There we go. Sorry, that first option is how many lists, sorry, not which list. So how many lists do I want to do this to? I only want to do it to one list, and that is list 1. And then it puts it into ascending order. So we can see there we've got 156 like we had here, 159, 161, and it just makes it so much easier to read off the data that way and make sure that we're putting it in the correct order in our stem and leaf diagram. And that's really important, especially if you have a large set of numbers that you are having to put in order. And we end up doing this in different areas of statistics. So this is going to come up again where we're having to put numbers into a certain order. So it's quite a useful thing to use in your calculator. Now, taking stem and leaf diagrams a little bit further than you probably have seen before, if we have a quick look at back-to-back stem and leaf diagrams, so this it's where we're having to represent two sets of data at the same time on a single stem and leaf diagram, and it's called a back-to-back stem and leaf diagram, and it works on the same premise as a normal stem and leaf diagram. So you can see here they've already given us the setup for this, and we're having to put these numbers into order. Now, if I use this function that I've just showed you on my calculator to make things a bit easier, delete what I've already got in there. So I'm just going to put each set in separately. I'm going to put A into list 1, B into list 2, and I'm going to try and get the calculator to sort both lists at once for me. So I've got 55, 39, 33, 21, 57, 40, 33, 52, 47, 24, 31, 26. Then in B, I've got 27, 59, 22, 47, 33, 56, 27, 39, 43, 27, and 53. So, just going to check, because I've got two different amounts of data there, so that means I've missed something because it was the same amount in the question. So 55 and 27, yeah. 39 and 59, yeah. 33 and 22, yeah. 21 and 47, yeah. 57 and, that should say 33, not 22. 40 and 56, 33 and 27, 52 and 24. This is where it's gone wrong, yeah. 47 and 39, 24 and 43, 31 and 27, and 26 and 53. There we go. And that's why it's always really important that we do double check the data that we've put into our calculator before we go any further, because after I've done this, I'm just going to be reading it off my calculator and not referring back to the data. You could always use the data just to double check that you do have them all in the correct order. So remember, usually we start off on this screen here with the graph calc test introdist. If I go across one, so using the F6 button, F1 gets up my tools. I want to sort into ascending order, two lists, which is going to be list 1 and list 2. So hopefully that worked for the first list and not the second list. Sorry, I've just fully realised what that does in your calculator. So if you tell it to sort two lists, it doesn't work. What it does is that it does sort the first list into ascending order. That's the base list. But then the secondary list if you have two numbers that are the same in list 1, then in list 2, it won't put the corresponding number that went with that. It will put the smallest number that was paired with that number first, and then the second biggest number. So you can only sort one list at once. So I do apologise for that. Anyway, we're going to do A first then, because that one I've sorted into order, and then we'll sort list B. So we've got 21. So my first bit here, just double checking in the other group that there's nothing in the teens, and there isn't. So 21, so my first stem is going to be a 2. Then I've got a 1 for the 21, a 4 for the 24, and a 6 for the 26. So that's the 20s done. Then for the next one, a 3 in the stem, a 1 for the 31, 2 3s for the 2 33s, a 9 for the 39, that's it for the 30s. Then a 4, we've got 40 and 47. On to the 50s. We've got 52, 55 and 57. You can see again, I've tried to keep the numbers in columns. Now if we sort list 2, so how many lists? One list. Which list do I want to sort? List 2. So that's put list 2 in order now. So now we've got leaf B. Our stem is 2, we've got 22. Now instead of starting on the left hand side this time, I'm going to start at the right hand side and work my way out. So 22, then 24, then 27, then another 27, then another 27, and then we're on to 30s, 33, 39, nothing else there. Then on to the 40s, we've got 43 and 47. Then on to the 50s, we've got 53, 56 and 59. Now you can see again my columns that the numbers go into, so I can see the distribution of the data. Okay, so our key is going to be 2/6 represents 26. We haven't got any units up here, so it's just 26. Now if we were to compare this data here, we can see here that they don't follow a strict sense of skew. I guess that you could argue that they both have more data near the beginning than they do towards the end. So remember that that would be a positive skew. If I just quickly get back up our skew table, you can see here more data towards the beginning than the end. That means it's a positive skew. So both A and B have a slight positive skew. You could probably even argue that this data here is bimodal. Got a long one here and a long one here, and the two in the middle are the same. Okay, there's lots of different ways that we could think about that. If we have a look at the actual data, we can easily see the range of the data if we wanted to. So the range for this side would be 57 minus 21, which gives us 36. On this side, our range would be 59 minus 22, which gives us 37. So they're similarly spread, the data. If we wanted to have a look at the mode, we can see here The only numbers that are duplicated are these 7s here, which means that the mode would be 27. If we had a look on this side here, the only numbers that are repeated are the 3s, so the mode would be 33. And again, we could do the crossing out to help us to find the median. So that would be this side, A, doing it the exact same as what we did on the single stem and leaf diagram. That one that way, that one that way. Remembering that when you're working from the top, it goes onto that line. When you're working from the bottom, it goes onto that line. So it's going to be halfway between 33 and 39. You can double check that you've got 6 on either side. So halfway between 33 and 39 gives us 36. Here for the median, again, working from the beginning on this bit. So the first number here is 22. The last number here is 59. Bit different this time. So it's going to be halfway between 33 and 39, so that's also going to be 36. Again, instead of crossing off, you could just put all the numbers into your calculator and read off the median that way. But if we were to be asked how would we use a stem and leaf diagram to find the median, that's how we would do it. Okay, I want you to pause the video quickly and try the Now You Try. If you find it really easy, maybe try and stretch yourself a little bit and try and find the extra 3 bits of information that I just found for the back and back stem and leaf diagram. Okay, so hopefully you've given this a try. As you can see, I've drawn it, I've filled in the key, and I found most of the extra bits that I was talking about before. I wanted to show this before I started crossing off for the median so it was easier to read, so that you can check that you've got the numbers in the right place. Again, try and make sure you've got them in the columns. So then crossing off quickly, as I said before, you can just put the numbers in your calculator. I'm doing this to show how you would do it if you didn't have a calculator. So we've got, whoops, I've done those 2 the wrong way around. Let me try that again. There we go. So it's halfway between 405 and 401, which gives us 403. And on this side, it's going to be 405. Now this time, if we have a look at the data, we can see that it's just the first 2 groups that have a bit more data. So we could say that both of the data sets, choose a colour that's easier to read, so you could say that both A and B follow the same distribution and then you could call it slight, positive, or almost symmetrical. Now the big downfall with using a stem and leaf diagram, still if you were to do it with a large set of data, it would take a lot of time. Even if you use the calculator to help you to put the data into order, just drawing the stem and leaf diagram out would take a lot of time. It's easy to make mistakes because it's done by hand. And also, if we use it only for small data like what we have here, it's hard to say that you've actually found much, because all we've got here is 10 numbers that we've put into order. That's it. So even that slight discrepancy of having an extra number in both groups in the 390 category has meant that we couldn't say that the data was symmetrically distributed. However, if we did do this with a very large set of data, then it would be a lot easier to use it as a reference point for the distribution of the data. It only gives us a rough idea of how the data is being distributed. There are other methods that are much easier to use. However, it does give us an idea of the shape of the graph if we did want to use one of these. Thank you very much for listening.